Before we can get into a discussion about VLANs, we must first discuss and understand LANs. Now, the word LAN is an acronym for Local Area Networks, and the acronym VLAN stands for Virtual Local Area Network. So what is a LAN? No doubt you've used one. In fact, you're probably on one right now. A LAN is a localized group of computers that share common infrastructure, communication paths, and policy enforcement. When we say localized, we mean within the immediate vicinity. If your business has multiple locations, each location will have a separate LAN. If you have multiple floors in your office, there's a good likelihood that each floor will have separate LANs. And if your business requires, each department or job function can have their own separate LAN. Also, there are a few other things that characterize a LAN. For the most part, LANs are very fast, especially when compared to the speed of your internet connection. You'll also find that you are always accessing the same services as everyone else on your LAN, like printers, faxes, servers, and shared directories. And even though you may not always notice it, you also fall under the same umbrella of security as the rest of the users in your LAN. Now, one very important component to these LANs has to do with a particular communication type, the broadcast. The best way for me to describe broadcast traffic is with an analogy. Let's say that some company has a new product. The company has decided to use a mailer to advertise the new product. The company could choose to go to the post office and purchase a zip code, then send the mailer to all the residents of that particular zip code. Or if they're more sophisticated, they can choose to purchase a demographic list to target their mailer to a particular market. Once they have their list, they broadcast the mailer to everyone on their list. Now, they don't do this with the expectation that all recipients will purchase their product. They hope for that, but realistically, they only expect a few responses to the mailer broadcast. The same type of communication happens on your LANs. Let's say a particular host on your LAN has a message. In this case, let's say our laptop wants to find the internet connection. It will broadcast the message to all the hosts on the LAN. The hosts that do not need the message will discard it, while the host that does need it will respond accordingly. You may have noticed in a lot of our drawings we have this strange symbol. This is a router. And when we talk about broadcasts, we must recognize that the router has a very important job in handling broadcasts. But let me back up. Routers connect to your LANs, and they receive broadcasts. Also, they receive unicast traffic from your LAN. In fact, routers can potentially connect to many different LANs, and on each one of those LANs, they receive unicasts and broadcasts. And while the router can respond to the broadcasts on each LAN and forward unicasts between LANs, it will never forward broadcasts between LANs. So the broadcast from a single LAN can never radiate onto another LAN through a router. And this functionality of creating broadcast segments introduces the term broadcast domain, where each segment off of a router is its own isolated broadcast region or broadcast domain. Also, we have been using this green line to represent a LAN. In reality, there are very few LANs nowadays that connect all hosts via a single wire. What the green line represents is another device, or a series of interconnected devices, called a switch. A switch is a device to which all LAN hosts should connect. But the reason that we do not represent the device in our drawings is because it does not throw away broadcast traffic, but rather forwards broadcast traffic out all interfaces of the configured LAN. But what happens if you have more ports than you have hosts on a single LAN? Or what if the switch doesn't have enough ports? Well, this is where the true beauty of a switch comes in. First, even though a switch forwards broadcast traffic for the LAN, it can still segment broadcast domains. It does this with VLANs. VLANs are virtual instances of LANs, and each individual port of a switch can be assigned to a particular VLAN. And since the switch segments broadcast domains with the VLAN technology, the broadcast traffic from one VLAN will never bleed over into another VLAN. And to create higher port density, switches can be connected together and share VLANs with the use of trunk ports. So the advantages of VLANs and switches are that they aggregate LANs into a single device or device type. They make the administration of a LAN simpler by decreasing the amount of overhead required for cabling, provisioning, and maintenance, and they do all of this while giving the administrator a more robust tool set of features to use. We will explore these features further in the following movies, and thank you for watching this overview of VLANs.